So this is the back half of section 5.7. When I look at the four problems on the screen, I see even exponents to start the problem off, and when I see even exponents, I think squares when there's two terms, but this is going to be a special problem. In problem 24, 3 isn't a perfect square, it's not a perfect cube, and that's troubling. On 24, it's not really written right now as a square or a cube. I need to get it rewritten by pulling out the common factor first. That's the first step of any factoring problem. And in 24, both the coefficients are 3. There's a common factor of 3. Both terms have a y, and the smaller exponent is a y to the first. So I'm going to factor out a 3y. Taking the 3's away from each, the first term had 4 y's. I factored out a y. I'm left with 3 y's. And then after the minus sign, I took the y away so I don't get a variable. When I factored out the 3, I should divide the 3 by 3 and get a 1. Now it looks like a cube. So I think it's going to be a cube problem. In fact, I know it's a cube problem, but I only can confirm it's a cube problem if for each term I can write it as something times itself 3 times. Y cubed is y times y times y, and 1 is 1 times 1 times 1. So I'm able to write it as a product of 3 identical factors, so it is a cube problem. So template, same sign, flip the sign, plus, first parentheses gets 1 from each group, 1 from the group of y's, 1 from the group of 1's. Second parentheses, I pair the first set of y's and get y times y, which is y squared. I pair the y and the 1, I multiply those and get 1y. I pair the 1 and the 1, I multiply those and get 1. That's the answer, second parentheses always prime. Let's do 25 just to save some of your odd problems. In 25, it has 2 terms with an exponent of 2, so I think it's a square, but 2 and 8 aren't perfect squares. 25 is another problem that has a common factor. I'm going to factor out the common factor of 2 in problem 25 and be left with a parentheses that has x squared minus 4. That's a square with a minus. It has even exponents and 4 has a nice square root. So in 25, I'm going to be able to factor, and the template for factoring squares with minuses is one parentheses gets a plus, the other gets a minus. And for the variable, you divide the exponent by 2. Because the x is in the first position, I'm going to split that x up evenly into the first positions. And for any constant, you square root them. The 4 is going to turn into a 2 in my answer. And because the 4 is after the sign, the square root of 4 goes after the sign. So for an answer for problem 26, I should have, for an answer for problem 25, I should have exactly that. 2 times x plus 2 times x minus 2. 27 and 28 aren't prime because they have common factors. In 28, if I was factoring it, I'd pull out a common factor of a 2 and be left with a b squared plus 4. Now, I don't have a cube problem because the exponent isn't 3. It's a square problem with a plus. And square problems with minuses factor, square problems with pluses are prime. I can't call the whole problem prime because I was able to at least one parentheses factor, but I can't go further. This would be an answer for 28. Your 27 is going to have a similar answer. Hey, grouping problems. So 4 grouping problems, how nice. 30 I'm going to group. I'm going to put the first 2 terms in a parentheses, and I'm going to put the second 2 terms in a parentheses. In the second parentheses, I'm going to stuff the negative sign inside. Anytime I see 4 terms, I try factoring by grouping. It's my only go-to technique for 4 terms. My first parentheses, I'm going to factor out an x and be left with a 2x minus 3. The second parentheses, I stuff the negative inside, so I need to factor out a negative. The biggest number that divides evenly into 8 and 12 is 4, so I'll get a 4 out front. Both terms don't have an x, so I won't get an x out front. To fill up that parentheses, because I factored out a negative, I need to switch the signs. Because I factored out a 4, I need to divide by 4. So first term, I factored out a negative. That negative sign is going to flip to positive. I factored out a 4. I'll divide that 8 by 4 and get a 2. I'll leave the x. Next, that plus sign is going to change to minus because I factored out a negative. That 12, I'm going to divide by 4 and get a 3. Now I'm good. I can write the common parentheses as one of my factors, and what's in front of the common parentheses as another one of my factors. Let's do 31 together. 31, 4 terms, I'm going to do grouping. Even though I could rewrite it if I care to, I like grouping. There's hardly a reason to run away from it. I snuck a 1 in front of the second x, but not the first x, just because I kind of knew it was going to be needed. And the 1 in front of the first x squared wasn't going to be needed. So introduced my first parentheses and my second parentheses, made the sign between as opposed to inside because it's a plus. First parentheses, I'm going to factor out an x. The first term had 2 x's. I take 1 x away, I'm left with 1 x. I'm factoring out positive, so I'm not changing signs. The 1x, I took the x away, I'm left with the 1. That's why I left a 1 there, because I knew I needed it. In the second parentheses, both of the terms have a 24, so I'm going to factor out a 24. The second term doesn't have an x, so I can't factor out an x. I'm just going to factor out a positive 24. First term, if I factor out a positive 24, divide by 24, the constant goes away, I'm left with the x. I'm not changing signs because I didn't factor out a negative. The second term, the 24 that I factored out, I divide the 24 by that 24, and I get a 1. Now I see my common parentheses, which is going to be one of my factors in my answer, and what's in front of the common parentheses is going to be the other factor. Of course, you can flip-flop the order. It makes no difference if you would have written x plus 24 first and x plus 1 second. Both equally good. (33) and 34, 3 terms, no common factor, a number in front of the squared term, grouping. 3 terms, no common factor, no number in front of the squared term, sight factor. This evil number right there, if there wasn't a 2 there, I would sight factor, but because of that 2, that means I need to recalibrate and factor by grouping. So in problem 34, to do the grouping, I multiply the first and the last number and get 18. Don't have to worry about signs, there's no minuses, so these are double pluses. I write the double plus factors of 18, which are 1 times 18, 2 times 9, and 3 times 6. I add these. 1 plus 18 is 19. 2 plus 9 is 11. 3 plus 6 is 9. I need the 3 and the 6 because they give me the 9 that I haven't played with yet. So I'm going to use the 3 and the 6, and specifically I'm going to take the 9x, that's the middle term, and I'm going to rewrite it as 3x plus 6x. It wouldn't be any less or more correct had I written 6x plus 3x. So I'm going to rewrite this problem as 2x squared plus 3x plus 6x plus 9. Have it written with 4 terms so I can introduce my parentheses. Parentheses, parentheses. First two terms, in my first parentheses, I'll factor out an x and be left with a 2x plus 3. Second parentheses, the largest number that divides evenly into 6 and 9 is 3, so I'll factor out a 3. Both terms don't have an x, so I can't factor out an x. Now I'll divide the numbers inside the second parentheses by 3. The 6 divided by 3 will give me a 2. I'll leave the x before the plus sign. The 9 divided by 3 will give me 3. Now I have a common factor or common parentheses that I can't seem to write down. And in either order, one of your factors needs to be an x plus 3. The second factor or the opposite factor needs to be 2x plus 3. Let's do 35 together. 35 leads with a negative. Absolutely guaranteed that my template that I have for factoring trinomials doesn't work when there's a negative in front of the first term. In 35, there's not a common factor to worry about, but I do need to factor out a negative 1. So I'm going to factor out a negative 1. I could have just written a negative sign in front of the parentheses. I prefer the 1. A lot of teachers would like just the negative sign without the 1. Matters not. Flip the signs now. The negative x squared goes to positive x squared. The positive 5 goes to negative 5 with the x. The positive 6 goes to negative 6. Inside the parentheses, I don't have a number in front of the squared term. I shouldn't factor by grouping even though I could. It's just inefficient. I'm going to leave the common factor of negative 1 and use my template. That's the bottom row of my template. I'm looking for plus minus numbers, smaller number positive. So the number that I'm targeting is this negative 6 at the end of that parentheses. And I need plus minus, smaller one positive, bigger one negative. So my choices would be 1 and negative 6, 2 and negative 3. Now I'll add these. I'll do 1 plus negative 6 and 2 plus negative 3. Numbers have opposite signs, so I subtract. 1 plus negative 6 is negative 5. 2 plus negative 3 is negative 1. I'm searching for a negative 5, so the pair that I need are 1 and negative 6. Those are the numbers that are going to end my parentheses. To start my parentheses, I'm going to split the x squared evenly between the fronts of the parentheses, and by splitting it, I'm going to divide its exponent by 2 and get an x to the first to lead off my parentheses. And then to end my parentheses, I just take the numbers with the sign, positive 1 and negative 6. For an answer, you don't need the 1 in front of the parentheses, and you can flip-flop the order of the parentheses. It makes no difference if you prefer that to what I have written. (37) and 38, ugly. I knew the end part had ugliness in it. In 38, the first term is negative. I need to at least factor out a negative. And I look at the coefficients without the signs. 6, 30, and 24. 6 is 1 times 6. 30 is 5 times 6. 24 is 4 times 6. The greatest common factor between the three numbers is 6. So along with my negative sign, I'm going to pull out the common factor of 6. I don't get to put a y in front of my parentheses because the 24 doesn't have a y. So I have my common factor isolated with the negative. Now I'm going to change the signs and divide by 6. The negative 6y squared, I change the negative sign to positive. I divide the 6 by 6 and get 1. So I'm going to lead off with a y squared. Next term, I change the negative sign to positive. I divide the 30 by 6 and get a 5. I leave the y. Last term, I change the negative sign to positive. I take 24 and divide it by 6 and get 4. The negative 6 is going to be part of my answer. And I don't need grouping because there's not a number in front of the square term. I can just cite factor. I'm going to pull this 4 off, and I'm going to write double positive factors of 4. 1 and 4, and 2 and 2. And I'm going to add them. 1 plus 4 is 5. 2 plus 2 is 4. I know the numbers I'm going to need are the 1 and 4 because those are the pair that gave me the 5. Those are the numbers that are going to end my parentheses. I'm going to split the y squared evenly after I divide its exponent by 2 and write it up front in the parentheses. So my parentheses are going to start with a couple of y's, and they're going to end with a positive 1 and a positive 4. Always I can flip-flop my parentheses. There isn't ever anything magical about the order I write the parentheses in, and as near as I know, there's no preferred way to write these. Let's do 39 together. So 39, 3 terms, no number in front of the square term, so I shouldn't group. No common factor, and it doesn't start with a negative. I can go straight into factoring if I know the signs that I need to worry about. Minus and plus, I need double negative signs. So I'm going to look at this 4 and write the double negative factors. 4 is negative 1 times negative 2. 4 is also negative 2 times negative 2. 4 is negative 1 times 4 is negative 1 times negative 4, and 4 is negative 2 times negative 2. Sorry. Let me add these. Negative 1 plus negative 4 is negative 5. Negative 2 plus negative 2 is negative 4. I must need the negative 1 and the negative 4 because they give me the negative 5 that's staring at me in the middle. Create my 2 parentheses. Z's go up front, divide the exponent by 2, make the firsts in each parentheses the same, fill in my numbers of minus 1 and minus 4. I'll do 42, you can do 41. For 42, trying to factor y squared minus 23y minus 24. It's a cite factor. It's 3 terms, but there's not a number in front of the square term. If there was a number in front of the square term and I couldn't factor it out as a GCF, I'd have to write as 4 terms and factor by grouping. Another one with the bottom row of my template. I think this is the hardest row of the template, so I like to beat it up. So I need minus, plus, plus, minus numbers, smaller number, positive. So for the minus 24, I need to either be 1 in minus 24, 2 in minus 12, 3 in minus 8, or 4 in minus 6. I need to find the pair that give me the minus 23, and I'm going to get it real quickly. First line, I go 1 plus negative 24. Those numbers have opposite signs, so I subtract, take the sign of the larger. There's the negative 23. No need to go down that list. I have the pair that I need. I'm going to put in my parentheses, after the variables, a 1 and a negative 24. So I'm going to split the y squared up as a couple of y's to lead off my parentheses, and then with the signs, put the numbers in. Plus 1 and minus 24. Of course, you could do minus 24 and plus 1. Last problem. Another double minus. I like those. I'm going to do 44. So 44 is a squared minus 2a minus 3. I think I can cite factor. It's 3 terms. There's not a number in front of the squareds. I think I'm going to wind up splitting the a squareds up front Last row of my template again, I'm going to try to get that -3. I'm going to do small number plus, big number minus. The only numbers I know that multiply to -3, small number plus, big number minus, are 1 and -3. I'm going to add those. 1 plus -3 is -2. That means that's a good pair because that's what I was trying to get. I'm trying to get the pair that multiplies what it needs to multiply to with the correct sizes of the signs and adds to the middle number. So I'm going to get a +1 and a -3. Of course, I could do a -3 and a +1. We have 2 more sections to do. 5-8 is a long section. It's probably going to be 3, possibly 4 parts to the video. And then 5-9 is word problems. So get this stuff down really well before we jump into section 5-8, because in section 5-8 your factoring skills are going to be really important.